Welcome to this evening's keynote on Telemetry and Live Dashboard, which are truly some Elixir ecosystem superpowers. Also, how cute are these superheroes that I stole from the internet? Don't tell anyone. Moving on. All right, so a little bit about me, although I think that introduction was excellent. So thank you again. I'm Sophie. I'm a senior engineer at GitHub. I'm a maintainer of Elixir School. I'm a host of the Elixir Mix podcast together with some other very awesome, smart people. Definitely recommend checking it out. And I'm also a graduate and former teacher at the Flatiron School, as well as a dog owner. You can find me on the internet mostly under my actual name because I'm not very creative. And in case anyone is unfamiliar with my dog, this is him looking very normal in the sunshine, and there'll be a normal amount of pictures of him sprinkled throughout this evening's talk. All right, so what are we going to cover in this evening's talk? A couple of topics here. We'll start out by talking about telemetry and observability. What are they? What do they have to do with each other? We'll take a look at building our very own hand-rolled telemetry pipeline. Then we're going to take a look at how Telemetry and Live Dashboard work together in Phoenix 1.5. Finally, we'll wrap up with a brief look at some of the out-of-the-box telemetry events that we get for free from Phoenix and Ecto. And lastly, a discussion of why telemetry matters, because it really does. So, telemetry and observability. What are they? What do they have to do with one another? I want to take a step back first and just kind of talk about what observability is. It's a word that gets thrown around a lot these days, and I think it's worth defining. So observability is the ability to understand what's happening inside our system by examining the system's output. Any one of us who has spent hours or days maybe debugging a production issue that you can't replicate locally, relying mostly on guesswork or institutional knowledge, definitely knows what it costs to lack this ability. And a lot of us have come to treat this situation as kind of normal. And while in the past it might have been the case that ensuring system observability required a specialized set of skills, it's increasingly not true of the world we live in. With third-party tools like Datadog, Splunk, Honeycomb, and you guessed it, libraries like Telemetry, web developers like you and me are empowered to treat observability like the first-class citizen that it really is. So to paraphrase Charity Majors, who is the co-founder of Honeycomb.io, in today's world, we can instrument our code, watch it deploy, and answer the question, is it doing what I expect? In this way, we can build systems that are both understandable and well understood. So what does telemetry have to do with it? Erlang's telemetry gives us this visibility. All right, so we want to observe things. We know it's great. Telemetry supposedly gives us that ability. What exactly is it? Telemetry is an open source suite of libraries that standardizes how apps on the beam are instrumented and monitored. How does it work? I think the blog post that came out from Erlang Solutions about a year ago introducing telemetry really says it best. So I've pulled a few quotes from there. At the core of telemetry lies the event. The event indicates that something happened. An HTTP request was accepted, a database query returned a result, a user signed in. Each of these events can have many handlers attached to it, each performing a specific action when the event is published. So for an example, an event handler might update a metric, log some data, or enrich the context of a distributed trace. And that's pretty much it. An event happens, telemetry knows about it, and does a thing. At a high level, it's pretty simple. So let's walk through how we can roll our own observability pipeline in Elixir using just the telemetry library. In order to use telemetry in our Elixir app, we will attach the event to a handler. We're going to execute our telemetry event, and then we'll handle that event. We're going to dig into each of these three steps now. First up, we will be attaching the event to a handler. So what does it mean to attach an event to a handler? This is a word you're going to hear a lot in the next 20-30 minutes. So one thing that really surprised me when I dug into telemetry and actually started looking through the source code, although we often use the published subscribe language to describe telemetry events, like we might say that an event was published or sent, telemetry doesn't rely on gen servers or message passing of any kind between processes to execute and handle events. Everything happens in process. Instead, it leverages ETS, which is Erlang term storage, the in-memory store that we can interact with using Erlang. So attaching an event to a handler really just means that we're storing the event name in an ETS table along with the handler function for that event. Pretty simple under the hood. And we do this with the help of the telemetry attach for function. This is how we store the event and its handler in the ets table. And we're going to take a look at an example now. So let's say I have a Phoenix web app called Quantum, so named because it's mainly responsible for measuring things. And I want to execute and respond to a telemetry event every time my app receives a web request. I'll need to attach the event to a handler, in other words, store the event name in ets with its corresponding handler function. And I'll need to make sure that this happens when the application starts up so that we don't miss any events. So to achieve that, we'll be calling telemetry attach for in our application start function. Let's pick this apart a little bit. We call telemetry attach for with the event name. In our case, we're going to name our event Phoenix request, pretty basic. So the event name that we want to store in ets. And we're also going to pass in the handler function that we want to call when that event is executed later. So I want telemetry to execute the handle event for function that we will implement in our very own custom quantum telemetry metrics module, which we're going to take a look at in a few minutes. So now that we've attached our event to a handler, let's take a look at event execution. Events are executed via a call to telemetry execute 3. And telemetry execute 3 is called with arguments of the event name, a measurement map, and some metadata. Under the hood, all it really does is look up the event in ets by its name and invoke the handler function with the measurement and metadata payloads. So revisiting the Phoenix request event that we attached to our handler earlier, let's say we want to execute our event from a controller action to indicate that our app has processed a web request. From whichever controller action, we would call telemetry execute for with our event name, the event measurement, which in our case, we've measured the duration of the request, and the event metadata. And here we're using the con or the connection object, which has lots of rich information in it. So now that we know how not only to attach our event, but also execute it, let's make sure it can be handled properly. Recall that we attached a handler for the event quantum telemetry handle event for, so we're going to define that module now. So the handler function that we're going to need to define in our module expects to be called with the event name, the measurement, and the metadata. So we're going to implement our handler module and the function, the ones that we're storing in ets, with our call to telemetry attach, and we're implementing the handle event for function that again expects to receive the event name, the event measurement, and the event metadata. So you'll notice that our handler doesn't do too much. It really just logs something, but you could imagine doing all kinds of things here. You could send something to stats-D. You could, I don't know, shoot a rocket into space, deploy a carrier pigeon. Anything you want to do in response to your telemetry event, you would do so here. So putting it all together, we have our attachment phase. We call telemetry attach when our application starts up, which really sets an entry in our ets table, setting the event name to its stored handler function. Later on, when our telemetry event is executed, we are looking it up in ets. We are getting the handler function for the event name and invoking it. That's it, pretty easy, sort of. It was actually kind of a lot of work, in my opinion. So we had to define our own handler module and function. We had to manually attach the event to the handler with a call to telemetry attach. We had to manually execute our telemetry event in some controller action. And on top of that, the more events we want to observe, the more work we need to do. We don't really feel like this scales very well. So wouldn't it be great if we didn't have to do basically any of this? If there was some abstraction around attaching, execution, and handling commonly observed events that we could opt into, that would be so great. Luckily for us, Phoenix 1.5 provides exactly this with the incorporation of telemetry metrics, as well as some out-of-the-box telemetry events that we'll see are executed directly from Phoenix and Ecto source code. So let's take a look at how telemetry is baked into Phoenix 1.5. In this section, we're going to cover some basics. We'll take a look at how the telemetry metrics module enables us to measure events. And then we'll talk about something that I'm very excited about, which is how Live Dashboard acts as a telemetry reporter for some of these events. So diving into some basics. Phoenix and Ecto do in fact execute a number of telemetry events for free right out of the box. There are events describing web requests, database queries, stuff like that. This actually isn't new to Phoenix 1.5 or recent Ecto releases, but Phoenix 1.5 now provides some new out-of-the-box ways of responding to these events, whereas before you had to roll your own telemetry implementations just like we did in the previous part of this talk. So we're going to take a closer look at some of these out-of-the-box events later on, but first I want to talk about this telemetry metrics module that I keep mentioning and how it allows us to measure and report on telemetry events. So Phoenix now ships with its own telemetry metrics module. When you Phoenix new, your new Phoenix 1.5 app, you're going to get this generated metrics module that uses the telemetry metrics module. And this is where we will define which telemetry events we want to handle and how. It abstracts away the need to manually define our own event handlers and manually attach events to those handlers. So the telemetry metrics module measures telemetry events and it reports them to a telemetry reporter for you. A telemetry reporter implements the event handler functions and it's responsible for attaching events to these handlers when the application starts up. So we do not have to call attach ourselves anymore. And the reporter also handles the events when they are executed because it's responsible for implementing the handler functions that it puts into X. So the reporter could be a number of things. It could be the console, it could be statsd, it could be Prometheus, or it could be LiveDashboard. LiveDashboard, for anyone who isn't yet familiar, is a library that integrates into your Phoenix web app and provides real-time performance monitoring and debugging tools for Phoenix developers just like you and me. Here's a look actually at the live dashboard for Elixir Company. Elixir Company is an open source project that lists companies using Elixir. We post job openings, stuff like that. You can actually visit the Elixir Company website. You can log in with your GitHub account and then you'll have access to this live dashboard. So here's a look at the live dashboard, which has a lot of powerful observability capabilities. But this evening, I want to focus just on the manner in which it reports and visualizes specifically telemetry events. So here we see a visualization of the Phoenix router dispatch stop event. We're going to talk a little bit more about this event in a little bit. And our visualization graphs the duration of web requests that the app has received, which is pretty helpful. And I want to take a closer look now at how this telemetry event specifically is executed and handled by Phoenix 1.5 and Live Dashboard. And the key to this capability is the telemetry metrics library. So measuring events with telemetry metrics. I want to trace the life cycle of this one event executed for us for free by Phoenix. We're going to look at how Phoenix executes this particular event, how we can configure our telemetry metrics module to measure the event, and how this event is reported to Live Dashboard for handling. The event we'll be examining is the Phoenix router event. And we're going to start with event execution. So earlier, you might recall that we created our own web request telemetry event and we executed it manually from our own web apps controller action. And again, this is too much work. It really doesn't scale. You don't want to be responsible for plopping that code into like every single controller action in your app. That's no good. Luckily for us, Phoenix source code executes a telemetry event for every single incoming web request when that request is done being processed successfully, and it does it from the router. So here we see telemetry's execute function called with the event name of Phoenix router dispatch stop and the measurement payload describing the request duration, as well as the metadata map, including the connection information. Pretty useful. So Phoenix's new out-of-the-box metrics module allows us to measure this telemetry event occurrence by mapping the Phoenix router event and lots of other Phoenix and Ecto events to specific types of metrics. And this teaches the telemetry reporter how to aggregate, format, and report on an event when it occurs. So for example, should the reporter treat an event occurrence as a counter that tracks, let's say, the sum of event occurrences over time, or you could say treat it as a gauge measurement, which would measure the value of an event at a given point in time. I want to take a closer look now at the telemetry metrics module that ships, again, with any new Phoenix 1.5 app. So all of the code that you're looking at in this slide was actually generated for us for free when we generated our new Phoenix 1.5 app. And we can see here that the metrics 0 function uses some telemetry metrics functions. We see counter and summary to specify which telemetry events to treat as which kinds of metrics. We're going to dig into this a little bit now. So here we're using the summary function, which tells the reporter to calculate the statistic of the selected measurement, like max, mean, percentiles, etc. And we also see the counter function, which tells the reporter to treat the event as a count metric, which is the total sum of the given event up until this point of time. Each of these functions takes in an argument of the telemetry event name. In our case, we're looking at the Phoenix router dispatch stop event, and returns a properly structured metric definition. The metrics definitions that are implemented in your metric 0 function are later used by the telemetry reporter. For example, the statsd reporter would send the metric to statsd, which would then aggregate it appropriately, while the live dashboard reporter will aggregate and format the metric and update the dashboard UI. So this brings us to the final step of our telemetry pipeline, which is handling the event. Which brings us to our next topic, the one I'm very excited for, Live Dashboard as a telemetry reporter. So Live Dashboard stores our telemetry events in ETS along with their metrics definitions and its own handler function. And it does this under the hood via a call to telemetry attach 4, not too surprising. So when the event is executed later, Live Dashboard's handlers are the one that are invoked, and they respond to event execution by updating the dashboard UI in real time. And it does all of this for us for free, which is so exciting. So just to kind of highlight what you would be responsible for as an application developer versus what's handled in the Live Dashboard framework, we define our telemetry metrics in the metrics module, although you do get a lot of generated metrics functions just when you make your new app. We are responsible for giving these metrics definitions to Live Dashboard, and we'll see how to do that in a moment. And then we're basically done. Live Dashboard takes it from there. Live Dashboard stores the events and metrics definitions in ETS with its own handler functions. And Live Dashboards handle the event later on when they're executed by updating the UI. So let's take a look at how this works. In this section, we're going to take a look at how Live Dashboard attaches these events, how Live Dashboard handles these events, and then we're going to put it all together. So attaching events in Live Dashboard. The code we're about to look at is the only code that we have to write in order to report telemetry events to Live Dashboard as metrics. All we have to do is mount the Live Dashboard route in our apps router and provide the name of our app's telemetry metrics module. So here in our router, we're mounting the Live Dashboard route with a call to the Live Dashboard macro and an argument of our metrics module, and that's it. This is where all the magic happens. This kicks off the process of attaching events to handlers. The Live Dashboard macro under the hood is going to map the dashboards/metrics route to a particular live view. And here we see that happen. It's mapping the route to the metrics live view. And when it does this, it's going to pass the metrics defined in our metrics module to that live view as ops. This is the result of calling, in our case, quantum telemetry metrics 0, which is not pictured here. So when metrics live starts up, it's going to attach our telemetry events to its own handler by calling under the hood telemetry listeners listen to function. So here we can see the mount function of the metrics live view, and it's going to invoke telemetry listener listen to with the metrics that got passed in from the router as an argument. Right here, metrics passed in via the router. What's it going to do under the hood? Under the hood, it's going to iterate over the events and their metrics definitions, and it's going to call telemetry attach 4 for each event. And it's going to call this with the event name, the metrics definitions for that event from our module, a PID referencing the metrics live view, and we're going to see why that's important later on, and its own handler function. In this case, handle metrics 4. So later, when the telemetry event is executed, this is the function that will be invoked. Let's kind of take a step back and put this attachment process together. So by mounting the Live Dashboard macro, the metrics live view is going to start up with an argument of our metrics from our metrics module. When the metrics live mounts, it's going to call telemetry listener, and it's going to invoke it with its own PID and these metrics definitions. When the telemetry listener is invoked, it's going to iterate over the metrics definitions, and for each event name, it's going to store it in ETS along with the metrics definition structure and its own handler func, so that it's ready to handle events when they are invoked. And let's take a look at this now. So as we've just seen, events are handled with telemetry listeners handle metrics 4 function. And what does it do under the hood? Under the hood, it's going to format the event measurements according to the metrics definitions that are stored in ETS. Here is a brief look. We're not going to get too into this code. It's doing some formatting. Hooray. And it's going to report these event measurements back up to the metrics live view for a UI update. So it's a good thing that the metrics live PID was stored in ETS, because now it's going to use that PID to send a message back to the metrics live view with the formatted telemetry event metrics. Metrics lives know how to respond to this message because it implements a handle info 2 for it. So what does it do when it receives this message? It updates the chart component state by calling the send update function. And this eventually will trigger your UI change. So we'll see any new metrics come in real time in this dashboard, which is pretty cool. So putting it all together on the handling side, let's say a user visits a particular route, let's say /login. This is going to execute an event for us for free under the hood from Phoenix source code. What that will do is look up the event and its handler in ETS. Our handler in this case is the telemetry listener handle metrics for function, which will format some metrics information for the event and send the message back up to the metrics live, which will in turn send an update to the chart component, which will re-render the template. Okay, so we looked at attaching, we looked at handling. Let's put it all together. The telemetry metrics metric 0 function is where we map telemetry events to metrics. We pass these metrics definitions to Live Dashboard in the router. Live Dashboard starts up its metrics live view with these metrics definitions. It calls telemetry attach for under the hood to store the event names and metrics definitions in ETS with its own handler, so that later when a telemetry event is executed, telemetry called the stored Live Dashboard handler function, which formats the event metrics and sends a message back to metrics live, which will update state and trigger a UI change. So we did it. We put it all together. We see how telemetry metrics and Live Dashboard work together. We don't have to write basically any code to get this working. Very, very exciting stuff. All the superheroes are so thrilled for us. So is my dog. He's beside himself. He's also pretty tired. So I think it's time to think about wrapping this up. So what have we seen? We've seen that telemetry is a really powerful tool. It gives us visibility into our Elixir application. It allows us to measure and monitor how our app is performing and behaving. And it makes observability a first-class citizen by building it right into the framework of Phoenix. So telemetry exposes the output of our system so that we can understand what's going on inside of it. True observability. Now that we understand just how powerful a tool telemetry is, I want to take a brief look at some of the useful events that Phoenix and Ecto execute for us for free right out of the box. And in doing so, I think we'll see what telemetry gives us the ability to measure and know about our system. So what does telemetry expose in our Elixir app? Let's take a look at some of Phoenix and Ecto's out-of-the-box telemetry events. I'll start by taking a look at some Phoenix telemetry events. This isn't going to be an exhaustive or comprehensive list, just a few highlights. So we've already seen the Phoenix router dispatch stop event. This is the event that we've been working with throughout the course of this talk. The Phoenix router module executes this event after the request is processed successfully by the plug pipeline and the controller, but before a response is rendered. We also have the Phoenix endpoint render errors event. It's going to be executed by the render errors module, and it's going to send out this telemetry event after rendering the error view. So once again, we see that the event is executed with the duration map and some metadata. Phoenix also provides some instrumentation for socket and channel interactions. The Phoenix socket module executes a telemetry event whenever the socket is connected to. So here you can see that the metadata contains info that it's going to include the endpoint, params, user socket, connection result, lots of good stuff, along with a payload of the duration. In other words, how long did it take for the socket to be successfully connected to. We also have some Phoenix channel events. The Phoenix channel server module executes 2 telemetry events, one when the channel is joined and one whenever channel invokes the handle and to function. So here duration describes the duration of the channel join function. In other words, how long did it take to go from receiving the channel join request to concluding it successfully or unsuccessfully. And it's also going to be invoked with some metadata that will include info like the socket, the user's auth information, the result of the channel join, etc. Something I'm super excited to see is a very recent addition to LiveView is that LiveView now also executes some telemetry events. So we're starting to see that we're going to get the same type of visibility into the behaviors of our WebSocket-powered Live Views that we're used to seeing for our regular HTTP web app behaviors. There's a lot of LiveView events. They're very well documented. We'll just take a brief look at some of these. So these events are dispatched with a time measurement, duration in the case of the stop event, and a metadata map containing socket, params, and session info. So we're going to execute some events when the LiveView is mounted. If there's an exception when it's mounted, we're going to execute a telemetry event if LiveView receives a handle event callback, or if there's an exception in handle event. And like I mentioned, there's a pretty comprehensive list in the LiveView documentation, and I think it's pretty powerful stuff. Lastly, we'll take a brief look at some Ecto telemetry events. So the repo query event, Ecto is going to execute this event for every query sent to your app's Ecto adapter. And it's going to execute the event with a measurement map and a metadata map. We're starting to see this as like the running theme. We execute events with measurements and metadata. So there's a lot of info that is actually going to be included in the repo query events measurement map. I just want to zero in on one aspect of it, which is total time, which is the total time it takes to execute a query and return results. Likewise, the metadata map actually has a ton of good info in it, but I just want to draw attention to a couple of the things in there. The metadata map is going to include the result, the query result, the params, the query parameters, as well as the query itself, the query string. So we can implement metrics for any of these events in our telemetry metrics module. And before we go, I want to do exactly that. I want to take a look at how we can implement some metrics for this repo query event. And in this example, we're going to see how we can leverage telemetry's tagging options to get the most information out of our telemetry events when they are handled and reported. So every telemetry metrics function, in this case, we're looking at the counter3 function, supports two options, tags and tag values. We can use the tag values option to store a function that will be called later on during the telemetry event handling process to construct additional tags from the metadata map with which telemetry executes a given event. We can use the tag option to specify the complete list of tags to be returned from the tag values func. So we need to implement a function that expects to receive the event metadata and returns a map that includes all of the tags we want to apply to our metric. So if we implement this function, if we specify our values exactly like this, we would see that if the following query is executed in our app, pretty simple, from you and users, where age is greater than 18, select name, we would see this metric reported, pictured here using the stats-d reporting format, which I think displays tags really nicely. So what did we learn? Tags are great. They allow us to measure and aggregate information-rich events. And we can use tags to measure things like failed and successful web requests by endpoint, Ecto queries by resource and query type, and so much more. In this way, telemetry allows us to build rich observability functionality directly into our applications. Wrapping up with why all of this matters. So with the native telemetry events executed by Phoenix, we gain visibility into the behavior of our web app. We can measure and report on things like average request times, we can identify slow endpoints, we can see when and where errors are spiking, and we can find out why. And the shiny new LiveView telemetry events allow us to gain the same kind of visibility that we're used to seeing for web requests, now for our WebSocket-powered Live Views. Meanwhile, Ecto events allow us to measure query times, identify slow and expensive queries, and so much more. All of this illustrates just how powerful a tool telemetry really is in our observability toolbox. It gives us first-class observability tooling. It standardizes how we as Elixir developers instrument our code in a way that isn't restrictive or even really opinionated at all about what we do with the events we observe. So what does this mean? This means libraries and apps that are easier to debug and maintain because they're easier to observe. This, of course, in turn means that we are happy and productive Elixir developers who are empowered to remediate issues quickly and efficiently. It leads to things like, for example, low mean time to resolution, which once again, not only makes us happy, but it means happy stakeholders too. And I think really all of this is going to add up to increased Elixir adoption. Telemetry is yet another ecosystem feature that makes Elixir a really compelling choice for teams and businesses. So we need you to adopt telemetry. If you're a library author, instrument your code using telemetry best practices. I think you're going to see increased library adoption as a result. If you're an application developer, instrument your code using telemetry best practices. Your first responders and your stakeholders will thank you. You'll find that telemetry makes your applications more robust and your teams more productive. And it really is one of Elixir's many superpowers. Thank you. Not a superhero, just a dog. some resources. That went a lot faster than I thought I would. Very impressed with myself as a result. So I think we probably do have time for questions.
Yep, lots of time. Shall we try and give Sophie a sort of closing round of applause? Great. So let me just check the panel here for questions. Oh, someone is asking about best practices, and that's Heiko. I think they should be able to unmute themselves, and so maybe they can ask that question on their own.
Yeah, can you hear me?
Yeah,
I can.
So I'm very new to Elixir, and that was interesting to this quick whirlwind tour through Telemetry from you. I would like to know what kind of best practices would you say are most important?
Yeah, absolutely. So the first thing I'll say is I'll point to this really excellent article from Chris Keithley, who's one of the telemetry contributors and maintainers. I linked to it here, but it's a hyperlink. There we go. So definitely recommend checking this out or just Googling it yourself, as well as checking out the telemetry documentation. But overall, you basically just want to think about like, what are the activities and events that I care about in my application? And then you generally want to execute an event for the start, stop, and exceptions that may occur within those events. So let's say you care about user login, think about start, stop, exception. Let's say your application consumes messages from a message bus and like processes payments. You want to think about start, stop, and execution of payment processing. So you might be thinking to yourself, well, having to execute 3 events for everything I care about seems kind of onerous. Luckily for us, there's a recent addition to the telemetry library called spanning. You can use the telemetry span function to wrap function calls, and it's going to execute a start, stop, and exception telemetry event for you for free based on what actually occurs in the function that you're wrapping. So definitely check out telemetry span. It's a really great tool.
right.
Could you write this down? How it's spelled, please?
Absolutely, yeah. Here, I'm actually going to show you guys. Is my screen still being shared or not?
Yep, we can see it.
Okay, great. So actually, if you just go over to the package, you can see here lots of good stuff, including some documentation on the span function right here.
So since there aren't any other questions on Q&A, before I ask one of my own, does anyone else want to come forward right here, right now? Just unmute yourselves and ask away. Okay, so I guess maybe a question from me. Is there a way to sort of put alarms in place? So set a threshold, say, and use that to trigger an alarm?
Yeah, absolutely. So I think, again, one of the great things about telemetry is that it's really unopinionated about what you're going to do in response to these events. So I think a really common pattern that you're going to see is you're going to identify what you care about in your app. You're going to use probably telemetry span to execute start, stop, exception events around those activities. And you're going to specify, you can specify any reporter, right? So we took a look at Live Dashboard and how it does so much for you for free by way of illustrating and giving you these real-time looks at how metrics are behaving in your app. But you're probably also going to end up defining some of your own handlers and attaching them either to events that you're executing yourself because they relate to, you know, your own business logic and behaviors, as well as potentially to some of the events that are executed for free from, like, let's say Phoenix and Ecto. So in your own handler, what you're going to do is probably some Prometheus or StatsD reporting. I think a lot of people are reaching for. There's a library called Statix, STATIX, which is like the Elixir wrapper for communicating with the StatsD agent. So in your handlers is where you're really free to implement any of your own logic around where I'm reporting and how. Yeah, maybe reporting thresholds. Personally, if I'm looking for like alerting and reporting thresholds, you're probably already using a tool like Datadog and you're probably going to set those thresholds there. But you could use telemetry with the StatsD reporter and the dog StatsD formatter, all of which are out of the box options for the telemetry metrics module. And you'll send all of your event executions to the DogStatsD agent, and they'll end up in Datadog. So there's lots of great integrations for working with these tools that you're probably pretty familiar with: Prometheus, Datadog, what have you.
Great. I missed the power of the handlers there.
Yeah, it's nice because Live Dashboard is the handler. It's a handler for you. So if you're just trying to get, some kind of out of the box instrumentation and observability, you don't need to define any handlers, which is great because for a lot of those use cases, you don't need to do anything specific with them. You just want to see what's going on, but you can define any of your own handlers and attach any of your own events to those handlers.
Thanks. So while I check the Woover app again, please come forward with questions if you have them. So it
Hang
looks
out
like
and stare at a slide. We should at least stare at a slide.
it looks like there are
no
more on Woover. So I think
okay.
Unless someone interrupts us very, very suddenly right now, I'm going to hand over to Francesco and Jim, who have some closing words for us. And maybe before I do that, I'll say thank you again, Sophie.
Thank you. And I'll go ahead and I'll stop sharing my screen. Thank you so much. Thanks, everyone.